Hello my dear students, welcome once again. So today I am going to discuss SAS criterion of similarity of two triangles. This is Theorem 6.5 of NCERT class 10 book. Okay, so what is the statement? What does this theorem state? If one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional, then the two triangles are similar. So what has been said here is, suppose we are having two triangles, suppose ABC and DEF. These are the two triangles that are given, and they are telling that angle A and angle D are equal. Means one of the angles, corresponding angles are equal, and the sides including these angles, two sides including these angles are proportional. Means AB by DE is equal to AC by DF, and angle A is equal to angle D. So these two conditions are given. Now what we need to prove? We need to prove that these two triangles are similar. Okay, so in order to prove similarity, we will proceed in this manner. First we will write given angle A is equal to angle D, and and AB by DE is equal to AC by DF. Okay, this much clear. Now to prove triangle ABC is similar to triangle DEF. Now in order to prove this one, we need to do a small construction. And what is that construction? We will just cut DP equal to AB and DQ equal to AC, and then we will join PQ. So what is the construction? Means ultimately what we are taking 2 points P and Q on DE and DF in such a manner that DP will be equal to AB and DQ is equal to AC. Okay, then we have joined PQ. Now what next we have to do? Now we will take two triangles ABC and DPQ. Which one? ABC and DPQ. Now when we are taking these two triangles into consideration, what we know about these two triangles? That AB is equal to DP by construction, then AC is equal to DQ, and this angle A is equal to angle D already given. So by SAS, see SAS condition of congruence, we can say that these two triangles ABC and DPQ are congruent. Once these two triangles are congruent, definitely their corresponding paths will be equal. So what can we say about these angles? This angle B will be equal to this angle P, and this angle C will be equal to this angle Q. So this can be considered to be from CPCT, that is corresponding part of congruent triangles. We can conclude that one. Okay. Now after proving that these two angles, pairs of angles are equal, now we can take AB by DE equal to AC by DF, that is already given. So instead of AB, can we write DP? See, because AB is equal to DP given, so what we are doing is, instead of AB I am writing DP by DE, instead of AC I am writing DQ by DF. So here we can just in the Theorem 6.3 also we did something like that, isn't it? Since our target is to achieve something, whatever is given we have to take the help of that one. Okay, so DP by DE is equal to DQ by DF. So just reversing the numerators and denominators, what we are going to get is DE by DP is equal to DF by DQ. Then DE by DP, I am subtracting 1 from both the sides. So ultimately, after doing this one, what we are getting is DE minus DP. Now see, DE minus DP, definitely that one is PE. So DE minus DP is PE, and DF minus DQ. See, DF minus DQ, that one will be QF. So ultimately we can write that PE by DP is equal to QF by DQ. That again reversing that one, DP by PE is equal to DQ by QF. See, DP by PE, from this one PE by DP equal to QF by DQ. Then just reversing that one, we got DP by PE is equal to DQ by QF. Okay. So we have got DP by PE equal to DQ by QF. So we know that by basic proportionality theorem, we can conclude that, not basic, the converse. What was the converse of basic proportionality theorem? it was that if a line segment divides two sides of a triangle in the same ratio, then the two lines will be parallel. So since we have proved that, see, we have proved, isn't it? dP by PE is equal to dQ by QF. dP by PE is equal to dQ by QF. We have proved this one just now. Now, what can we say that? See here, dP by PE equal to dQ by QF. So by applying basic converse of the basic proportionality theorem, what does it state? It states that if a line segment is drawn in a triangle in such a manner that it divides two other sides in the same proportion, then this line will be parallel to the third side. Okay, so here we have proved dP by P equal to dQ by QF. Then just by the basic converse of basic proportionality theorem, we can say that yes, our PQ is parallel to EF. We have done this one. Okay, so we have said that yes, PQ is parallel to EF. Now once we say that PQ is parallel to EF, then again we can conclude something from the figure. If this line is parallel to this line, what can be said about these two angles? This angle and this angle will be corresponding angles. Similarly, this angle and this angle will be corresponding angles. So we can say that angle P will be equal to angle E, angle Q will be equal to angle F, isn't it? But earlier we have proved in the first part only that angle B is equal to P, and now we are proving that angle P is equal to E. So ultimately we can say that this angle B is equal to angle E, and this angle C was proved to be equal to Q, and now we are proving that Q is equal to F. So ultimately we can say that angle C is equal to F. So what can we say about this triangle? That in these two triangles ABC and DEF, we have proved that all the corresponding angles are equal. Okay. And we know that if in a triangle, see, triangle ABC and DEF, we have proved that all the corresponding angles are equal, then by angle similarity criterion, okay, angle similarity criterion, we can definitely say that these two triangles will be similar. So this is how we have proved this theorem. So go through it and try to understand. Here we have used some concepts about congruence and some concepts about the and one of the theorem, that is the converse of basic proportionality theorem, in order to prove this theorem. Thank you.